define, how do you write out the equation, and how do you find, excuse me, the sum of them? It's still 11.2. Yeah, this is still 11. Sorry about that. Remember yesterday we didn't finish out everything? This is still the same stuff. We just have a couple more examples to look at. So we're going to have another generic formula here. The sum of an arithmetic series is denoted by just the S for the sum, except they don't use sigma in this case. For however many of them you're looking for, S sub n. So if you want to find the sum of 13 of them, your n value would be 13. So if I want to find the sum of some amount is going to equal to however many you're looking for times the first term, the nth term, all over 2. Now, one of the things you might notice here is that a sub n. This a sub n stands for your nth rule. So you're going to be blending these equations together. No, it's not that bad. Trust me. It's not as bad trying to do your times table. Okay? Yeah. After 12, it's all bad things happen. So here's what it's going to look like. We're going to find the sum of this arithmetic series, and we're going to find the sum of the first 30 terms. Right? So we have an arithmetic series here at 4, 7, 10, 13, 16, 19, blah, 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 blah. Okay? Which means we have to write out a couple of different parts. We're still going to identify our first term. We're still going to identify our difference. We're still going to identify what this nth rule is because you're going to use it. From that, we're going to blend that into the sum of 30 of them. Okay? So in this case here, what is your difference? 3. What's your first term? 4. Good. So we start out with, we know our first term is 4. Our difference is 3. So that means our nth rule, when we substitute in those values, it's going to give us our rule for it. We get 4 plus n minus 1 times 3. When I distribute that out, combined like terms, you should get, wouldn't that be 3n plus 1?
Yeah.
Okay. So our nth rule in this case is 3n plus 1. Now it wants me to find the sum of 30 of them. Here's how this works. We'll come back to this part here in a little bit. When I want to find the sum of 30 of them, we're going to use the sum formula. Okay? Now, what's my n value going to stand for? 30. I want to find 30. Okay? So the sum of 30 of them is going to equal, well, 30 times 4. Very good. Now, I have to use a sub n where it's a sub 30. So where do I get that from? The other formula. I'll have to get that a30 here from 3 times 30 plus 1. What's your 30th term? 91. Everybody okay with that? Do you see how that works? Because you have to use the nth term to get the 30th term. You're using the nth rule to get that. So I know that my 30th term is 91. Okay? What's 4 plus 91?
95.
95. One of two things you can do here. What's half of 30? Nobody knows what half of 43 is.
Is he trying to get me to find out what I have? 95. 47.5 wrong. Ha! I was mad.
Instead of doing that, couldn't you just take half of 30 and multiply that by 95?
Yeah, you could, yeah.
You do that, or you can type it all in your calculator.
I think the calculator one.
Calculator works just fine. So what is the sum of 30 then?
30 is 1,425.
1,425.
But I use wrong original.
1425? So the sum of 30 of these would equal, thank you. Okay? It's not bad, is it? Do you see how you're blending it in between the two formulas to get to that point there using the arithmetic stuff?
Yeah.
Okay. The weird part then. The weird part. How many of them do you have to add together to equal 175? That's what you have to find out. So what you want to do here is you're doing the following. We're going to use, and I'm going to put these, I'm just going to put this on a separate sheet. Bless you.
Whoa.
All I'm doing here, guys, is that I'm using the same two formulas that we've had. The nth rule. I'm just putting it on a separate piece so that so it's easier to find. Separate sheet, separate page. Sorry. Now, what I'm doing here is we've already figured out what the nth rule is for that sequence. We know it's 3n plus 1. And we also know that the generic formula for the sum of the series would be that S sub n equals blah. Now what we want to do is we want to figure out what happens when S sub n, and you want to try and solve for that n value. We're reusing the same information from the original problem. What was your first term? 4. So I know that if I start substituting things in, I get 175 is 4. Oh, sorry. This is our n. We don't know what that is. The n is what we're trying to solve for. Okay?
Yeah.
4 plus, very good, all over 2. Everybody see that okay? We're using direct substitution. Can I combine anything?
Yeah.
4 and the 1.
4 and 1 is 5. Good. Could I also get rid of that divide by 2 by multiplying both sides by 2?
Yeah.
What's 175 double?
2.
No.
350.
Got it.
Yeah.
Yeah. Of course it's 3. Aaron, you should know that from math.
Very good. Distribute out, we get 3n squared plus 5n. I know everybody's going,
Wait, why are you squaring?
I'm distributing. And can I set the left side equal to 0?
Yeah, I have the minus.
Great.
This is great, isn't it? This is so much fun.
I'm sure you can do
Is there a GCF here?
5. No. No.
Maybe
1.
15.
1. No. This is what. But.
What? Did he say that?
Does
No.
3 go into all of these?
No.
No, so this is one of those types of factoring problems that you guys do not like. You have to multiply the first term and the last term. And that's a lot of work, isn't it?
It's like 11.
You can use the quadratic formula, absolutely. Now let me ask you this. Is there an easier way?
Probably.
Maybe.
You're going to show us.
Divide by. What do you do some butter?
Not necessarily a button. What I'd like you guys to do is take out your calculator, and I want to show you.
Hey, man. Back off.
Let's go to your y equals thing. Y equals real quick. I'd like you to put in that equation. It was 3x squared,
3.
5x, I believe.
Yeah.
minus 350. Okay? Now, if I graph that, it's going to be some parabola that you probably won't see on your screen. You see a little bit of it. Okay? Which is fine. I really don't need to look at it visually. But what I want you guys to think about here is go back to just that equation. What are you solving for here? Do you remember what that's called? The places where it crosses the axis. When you cross the axis, what do we call those? The intercepts. We also call it, starts with a Z and it ends in an zero.
Zero!
Very good. You guys are impressive. Okay? You're trying to solve for its zeros. Now, in this problem, can you tell me the types of zeros you're going to come up with? A negative and a positive. I should have rephrased that better. You picked up on that. What I meant is, can you tell me the signs of your zeros? Does everybody agree one of them will be positive and one will be negative? The reason of that is because you've got alternating signs here. Now, if I'm going to be adding up a bunch of values, when am I adding up, would I be looking for a positive zero or a negative zero? Think about what the question's asking us. The question is asking us, how many of these do we have to add together to get up to 175? If my answer is -3 and 6, am I adding -3 things to add up to 175, or am I adding 6 things to add up to 175? So I'm looking for my positive zero. In your calculator, you'll see this in 1 second. In your calculator, hit second table. I want you to scroll through, and I want to see if you can find the zero in the y column.
Yeah.
Where is it?
10.
All right. That means, how many does it take to add together?
So you just need to put it in your calculator and then just write the answer?
Now, there will be times that some of the factored ones are a lot easier. Yeah. The equation, what we put in our y equals here was the 3x squared plus 5x minus jump. Yeah. Okay. What do you got?
Is this going to be on the test where we can't use a calculator to solve that?
What'll happen on a test one, I would make sure that the factoring style ones would be ones that don't wind up with very super large numbers, ones that you can factor by hand. Maybe ones without the leading terms. Okay. Yes, sir.
Could you explain again what you mean by the positive and negative zero?
When you're graphing, remember this is called a parabola?
Yeah.
Okay. A lot of times when you're talking about a parabola, your parabola can go, it can cross up top. Oops, that didn't work. Let's try this again. A parabola is an x squared term. An x squared term can look a bunch of different ways. It could cross it in 2 spots. It can touch it at 1 spot. It could be positive. It could be negative. It could not touch it. It means there's no zeros. In next chapter, we're going to talk about parabolas that are turned upside down. Well, I'm sorry, sideways, where they'll cross x-axis, the y-axis is differently and stuff. But what's happening here is when you factor something, you have 2 spots that it could cross. Sometimes one of them is positive, one of them is negative. I'm looking for this case, since I'm adding, how many of them do I have to add together to get a value? I have to add 10 of them. I can't add negative 35 of them.
Okay.
Does that make sense?
Yeah.
That's what I'm saying, but I'm looking for the positive value. All right? Good question. All right? So yes, the calculator does help you out a lot when it comes to the factoring. So did I scare the bejesus out of you with the times table? Yes.
What did you scare us all with your eccentrics? Yeah.
I love scaring you guys. It's like the best day of my life when I get to do times tables. I hated it as a kid. All right, so first 10. Let's do. No, where is it? No, we're not doing this yet. I want to do another example here. Oh, that didn't work. like to do this one with you guys again real quick. Yes, yes. Same thing. We're going to do two things. I'd like to find the sum of 20 of them, and then I'd like to find out how many of them do you have to add together to make it equal to 366. It's basically mirroring the example we just did. I just happen to cut off the instructions. So you're going to blend the two equations again together. You'll start by writing out your nth rule. You'll use that nth rule within the sum of the series. And then after you do part A, reuse it, see if you can figure out part B. Take a couple minutes and try it.
Wait, what?
We're doing the same thing we just did.
Okay, how would
And I might have jumped to the gun here by giving you guys one right off the bat. You always start with the nth rule. Since you have to reuse the nth rule later, you want to write it out. So you know that the nth rule is your first term plus the n minus 1. What was your common difference here? 5. Good. So you're going to distribute and combine your like terms. So you get 5n minus 2. Okay. So your nth rule is 5n minus 2. You're going to reuse that a sub n when you use the sum of the series. Because the sum of the series is however many you're looking for times that first term plus whatever the nth term is over 2. Okay? So in order to figure out what that a sub n, that nth term is within the series, you write out the generic rule because they're going to ask you, well, I want to add up 20 when n is 20. So 20 of them will be 5 times 20 minus 2. The 20th term is, very good, 98. So the 20th term is 98 in that sequence.
Yeah.
Right? So the sum of 20 of them would be 20. First term of 3 plus the 98 all over 2. Yes, ma'am. Where did I get this equation here? In the red?
In the red.
8 20 plus 5, 1 times 20 minus 2.
I'm using n is 20. So I have to figure out what the 20th term is because the 20th term goes there. I use the nth term. In order to figure out what the 20th term is, I have to figure out what the nth term is to substitute 20 in for n. There's a lot of substitution going in here.
Wait, so then did you figure that out? That
All I did there was just substitute in yet. I haven't solved anything for what, however 20 of them are going to add up to equal.
But like, do you solve that?
Yeah, you will. I just have not there yet. All right? Because now, once you substitute in, you figure out what your 20th term is. The 20th term in that sequence would be 98. The first term is 3. The 20th term is 98. I add them together, divide it by 2, and then multiply it by 20. Or, what's 3 plus 98?
Oh, so
Oh,
I got the right answer.
There's your answer. That if you add up 20 of these, you get 1,010. Okay? Does that make sense on that? Now, when you go to figure out how many you need to add together to get up to 366, we work a little bit differently. I know if I want to find out the sum, how many of them I have to add together to equal 366. Move this up a bit. I use the sum And I'm just going to substitute in everything that I know. I know that 366 has to equal n. First term was 3, correct? First term. Our nth rule was, thank you. What's that? And then you get rid of that divide by 2. And what is that?
732.
Thank you. 732? Thank you. Actually, it's 10:07.
I got that one.
Well, it's divided, but I put it on and then I realized it was broken.
At least we write twice a day.
I keep changing it to the right thing, so it looks like it's a little.
Now, inside the parentheses, does everybody agree that it's 5n plus 1?
Yeah.
Can I distribute the n and write it right away as 5n squared plus n? Is that okay? What, 5n plus 1? Distribute the n? Okay. All right. Now, do I have to set one side equal to 0?
Yeah.
Okay. It's okay. What are you going to use in your calculator now?
The y.
Is your y equals, look for your positive 0. 5n squared plus n minus 732.
Well,
12. Nice, isn't
I
it?
wish I knew that like a long time ago.
We can't give you guys all the tricks right away. My stomach's growling. Must be close to lunch. Yes, sir. Okay, then you typed it in something wrong. Did you use? That's okay, don't worry. Oh, give us some weird arrows. I bet you typed it in wrong. Yep, you wrote minus x. Okay. Not so bad, is it? All right. Let's do some work then. All right, it's the homework then tonight is going to be basically the same stuff. It's still 11 to. So this will start on this probably. I think this starts on 664 then. It's numbers 45. Oh, we'll start at 46. I think I just did 45. 46 through 50, and then 58 and 60. Yeah.
And 60? Or 58, 59?
58 and 60. Yeah, comma 60. Thank you for clearing that out. All right. Those first 5 of them mirror the 2 examples we just did in class. It's exactly the same thing. The last 2 are some very simple word problems I want to get you guys in the habit of reading through. They're very easy to work with. I do, because you guys will see more and more of those throughout the school year. You'll be surprised at how easy word problems really are. There's tricks. Okay? We're going to start the geometric stuff. Look for the video.
I got it.
It's
Later.
It's
My birthday's on a Saturday.